Hey, hi everyone. So let's now discuss the integration leading to inverse trigonometric functions. So let's say you have an integral that looks like this. If you integrate this, it will be just the inverse trigonometric function. And also based on on your calculus one, if you find the derivative of arcsine u, the derivative of arcsine u is du over the square root of 1 minus u squared. So basically, if we do this the other way around, if we integrate this, no, for both of this, ayan. So the integral of this and this, so we have integral of du over the square root of 1 minus u squared, okay, is equal to arcsine, no? So I'll just write here arcsine u plus c, okay? So this will be one of the formulas that you can use for finding the integral of a function that looks like this. No? So we have d over the square root of 1 minus u squared. So we have three functions that can be integrated that will lead into an inverse trigonometric function. And you have to remember which of the three will be that. Ano? So for the first one, we have du over the square root of a squared. So a here is constant. Okay. U here is a variable or in general a function, no? A function. Okay. So we have a constant squared minus u squared. That is equal to arcsine u over a. And then for du or the integral of d over a squared plus u squared, we have 1 over a arctangent u over a plus c. And then for the last one, we have du over u, square root of u squared minus a squared. We have arcsecant u over a. Ano? So how is this derived? No? From your differential calculus, this is actually derived from the trigonometric identities. No? Okay, so let's move on and let's discuss an example. So we have dx over square root of 4 minus x squared. So how do we solve for this? So if you remember, the integral of du over the square root of a squared minus u squared is equal to arcsine u over a, okay, and then plus c. So does it look like this? So the answer is yes. So the a squared here is equal to 4. The u squared here is equal to x squared. So this a squared can reduce, no? So we can see that a is also equal to, so the square root of a squared is a, so the square root of 4 is 2, so a is equal to 2. Then if we want to solve this integral, okay, we already know the a and the u, no? So also the u, no? So u is equal to x. So therefore we could just substitute the values here. So therefore the integral again of dx over the square root of 4 minus x, 4 minus x squared, that is equal to arcsine u over a. So u is x, a is 2, and then plus c. So this will be your answer. It's that simple. No? Okay. The next one, we have this given function. So we have 80x over x times the square root of 4x squared minus 1. So how do we do this now? So what does this look like? So if you are familiar with the previous slide, so the integral of du over u times the square root of u squared minus a squared, that is equal to 1 over a arcsecant u plus c. Ano? So what should we do here? So we can let u, no? So as you can see here, the u here is x, no? So actually that is not the u, ano? So the u here should be this, no? So you should check for the inside first, ano? So u squared here is equal to 4x squared. Therefore, we can save after finding the square root of this. So this will become u. what is the square root of 4x squared? So the square root of 4x squared is the square root of 4, which is 2, and the square root of x squared, which is x. So u is actually 2x, no? And then for a squared, so a squared here is equal to 1, therefore a is equal to just 1, no? Square root of 1 is equal to 1. So we can rewrite this one. So let's rewrite this one, integral of 8 over x square root of 4x squared minus 1 dx. So we can rewrite this 4x squared into what? No? So we have u squared, right? So this will become u squared, okay, minus a squared. So 1 is now your a squared, right? And then, what about this? So we have x over 8, or 8 over x. So we know that x is equal to, u is equal to 2x. Therefore, we can say that x or u over 2 is equal to x. So we can substitute here u over 2. Now we have to change this x as well. We have u over 2. No, and then 8 here. The 8 will remain. And then actually we forgot to find the derivative. And also dx, we have to change this into the domain of u. So dx should also be changed. So finding the derivative of this, the derivative of u over 2 is du over 2. And then the derivative of x is just dx. So dx is equal to d over 2. We can write this one as du over 2. Yan. So simplify this one. What can we simplify here? Okay, so we can actually cancel this. Actually, we can cancel this. But to avoid confusion, I can write this 2 here. So this is also 2 times 8, right? So we can cancel this 2 here, and then this 2 here. So effectively, we can cancel this 2, we can cancel this 2. The 8 can be factored out. Okay. And we can simplify this problem into, so what remains is du over the square root of u, u times the square root of u squared minus a squared. Okay, so that does this look familiar? This is the form that we are looking for. So this will be the integral. So we have 1 over a arcsecant u, and we know that 1 over a, we have here 1 over 1, and then u here. Sorry, this should be over a pa pala, no? I always forget this. U over a. So we have already this given. So therefore the answer should be, so 8 here, and then the integral of this. So the integral of this is, you have 1 over a, so 1 over 1, arcsecant u over a. So u here is 2x, so 2x over a, so 1 plus c. So the final answer will be 8 arcsecant 2x plus c. Okay? Ayan lang. Next one. So evaluate this given integral. So how do we integrate this? Ayan. So as you can see, maybe we can try using u substitution. Okay? But I don't think it will work. Ano? We cannot cancel this for x if we let u is equal to x squared. You can try that one. So what are we familiar, or what formula are we familiar with that is close to this? So the closest one to this will be the integral of du over u squared plus a squared. Ano? So this integral is equal to arctangent, no? So we have 1 over a arctangent, okay? And then u over a plus c. So how do we do this now? So we have u squared plus a squared. So a is a constant. U here is a variable or function, no? So we have here, yes, we have an x squared, we have a constant, but we have negative 4x in between. So we cannot do that. But there is a technique that we can use. We can do the completing the square. So we can create this, or we can manipulate this x squared minus 4x. Ano? We can make this a complete square. So this will become a function u squared. So let's try that one. So we have x squared minus 4x. And then we can add here something. If we add something here, we have to subtract something as well. Ano? And then plus 7. So what should we add here to make this a complete square? So a complete square basically is, let's say we have x plus 1 squared. So that is a complete square. So what is the complete square of this? So we can add 4 here because x minus 4x plus 4 or x squared minus 4x plus 4, that is equal to x minus 2 squared. Ano? So if you do the FOIL method, it will reduce into this x squared minus 4x plus 4. So we can add here a 4. So if we add a 4 here, we have to also subtract a 4. So why is that? So that the function will still remain the same. In other words, we just expanded the function. It is still the same because this will cancel out. No? So plus 4 and negative 4 is just 0. So effectively, we just added 0. No? So this will now be equal to, we have here x minus 2 squared for this one. And then we can add these two numbers. We have negative 4 plus 7, which is 3. Okay, now, can we now integrate this using this formula? So the answer is yes. Ano? So this is already a function. No? It is not limited to just x squared. Ano? We can also do x minus 2 squared. So we know that this is your u squared and this is your a squared. So we can say that this is u squared is equal to x minus 2 squared. So therefore, u is equal to x minus 2, right? So finding the square root of this, we have u is equal to x minus 2. And then we have a squared is equal to 3. So finding the square root of this will be equal to, so a is equal to the square root of 3 naman. So therefore, we can rewrite this as, no? So don't forget as well, no? We have to change nga pala this dx as well. So using this, finding the derivative of du, we have du, okay? Sorry, the derivative of u is du, the derivative of x is dx. Derivative of negative 2 is 0, so we have du is equal to dx. So we have changed the dx into du, and then all over we have u squared plus a squared. No? So this is equal to, again, we have 1 over a arctangent u over a plus c. So therefore, we have 1 over a arctangent u over a. So therefore, the answer is 1 over the square root of 3, and then arctangent u over a. So u here is what? No? So u here is x minus 2. So we have x minus 2, and then all over a, which is square root of 3 plus c. So this will be your final answer. Okay? Or rationalizing this, we can rationalize this by multiplying, no, square root of 3 over 3 here. And also for this one. So we can also write the answer into square root of 3 over 3 arctangent. We have the square root of 3 times x minus 2 over 3 plus. So this is also the simplified answer if we want to rationalize the functions. Okay? And then I think this is the last one. So evaluate the given integrals. We have the integral of e raised to 3x dx over 9 plus e raised to 6x. Okay. So how do we do this now? You know? So what is the closest thing that we could do here? We can just use substitution, right? Maybe we can do that. No? But the problem lies when we find the derivative of this. Okay, this will still be e raised to 6x. You know? So 6 e raised to 6x, we cannot cancel this one. So an alternative, so this looks familiar actually, ano? So if you can remember, we have the integral again of u squared plus e squared, which is equal to 1 over a arctangent u over a plus c. So the u squared slightly resembles this, and the a squared slightly resembles this. So it is not obvious, But if we let u or u squared as this, so if we let u squared is equals to 6 e raised to 6x, no? So that basically means we are saying u squared is equal to e raised to 3x squared, right? So we can say that u is equal to e raised to 3x, ano? And if we find the derivative of this, finding the derivative of e raised if of this e raised to 3x. So this will be just 3e raised to 3x, ano? And then dx. And simplifying this, we have d over 3e raised to 3x. If we change this dx, no, if we substitute this dx, which is d over 3e raised to 3x, we can cancel out this e raised to 3x. Okay? So that will be the strategy, ano? And then don't forget this 9. So 9 is equal to, so e squared is equal to 9. So therefore we have a is equal to 3. Okay, now solving for this will be equal to, again, we have e raised to 3x. Substituting the dx, which is du over 3e raised to 3x. And then over, we have 9, so we have a squared. I can just write this as a squared for now. And then plus, we have u squared here for u, no? U squared is equal to 6x. So this will now be cancelled out. So we have 1/3 here. So 1/3 integral of du over a squared plus u squared. So what is the integral of this now? So the integral of this is, again, we have 1 over a arctangent q over a. So we have 1 over a. So what is a? A is equal to 3. Okay, so we have u over a. So arctangent u over a, arctan u over a. So u is equal to e raised to 3x. And then we have, what do you call this? A. So a here is equal to 3. So 3 in the denominator. And then don't forget the plus c. So simplifying this, we have 1/3 times 1/3. That is 3 over 3 and also 1 over 9. Arctangent e raised to 3x over 3 plus c. So this will be your final answer. Okay? So that will be all for this video. Thank you guys for listening.